Hey everybody, it's Mr. Carr again. Today we're going to be talking about 12.3 day 2. So we're going to continue with our general angles and start understanding a little bit more about our trigonomic functions of those. Okay, before we get started with any examples, what we want to focus in on is the signs that occur in each quadrant. Okay, so and it has to do with like the ending results are going to what the ending results are going to be after our trig. So for example, all of them are positive right here. Okay, so a sine of an angle, cosecant of an angle, cosine of an angle, secant of an angle, tangent and cotangent, all those angles, the result is going to be positive. Okay, so a little acronym that people have used in the past is all students take calculus. This is referring to which ones are positive in each quadrant. So if I look at all of them are positive here, which is what we see here. In the second quadrant, only sine is positive, which is what we're saying with this one. Since cosecant is the reciprocal of sine, cosecant is also positive. So they're both going to be together as both are going to be positive in that one. All students take calculus, so that is tangent here. And again, tangent and cotangent are the only positive ones in the third quadrant. The fourth quadrant, all students take calculus, so that's cosine. So again, only cosine and its reciprocal secant are the only ones that are positive in the fourth quadrant. Okay, so again, what this means is when we go through an example like this, we want to find the exact value of these different trig ratios. Okay, so we're going to go through these 4 steps every time. Draw the diagram for the given angle, determine which quadrant it is, so that's going to help us with the sign of the trig function, okay, and also get the reference angle. So this is what we practiced in the previous lesson. Then we write the expression with the info from step 2, and then we evaluate. So for example, sine of 135. Again, we're going to just want to duplicate this real quick. So we got a couple more. Yeah, let's just offset it a little bit. And then one more. Okay, so sine of 135 degrees. The key here is I need to draw 135 degrees. So I need to know where it goes. So if I do 180 minus 135, that gives me 45. So what that means is from 180 degrees, okay, sorry, put it right there. From 180 degrees, which is right here, it's going to be 45 degrees short of that. So I could just draw it right down the middle. Okay, so this is my 135 degrees. Now that creates the triangle like this. Okay, and instead of writing as theta, I'm going to write it as 45 here. So my reference triangle I need to use is going to be a 45, 45, 90 triangle. Okay, so I want to do the sine of that. Now, remember, all students take calculus, so this is going to be positive in this for sine. So sine, now I need to just find the sine of the 45. So if this is 1, 1, and root 2 for my reference triangle, that means the sine of 135 is equal to the opposite 1 over the square root of 2. If I rationalize that denominator, I multiply both root 2 to the numerator and denominator, so it becomes root 2 over 2. Okay, and that's the gist of it. So again, we drew the diagram, we figured out the quadrant we're in, the sign of the trig function, and which reference angle we did. Okay, then we figure out the sign of that by basing it on our reference triangle. So even though I did sine of 135, what I'm really doing is the sine of 45 is 1 over root 2. Okay, that's why that applied there. All right, cotangent of 7 pi over 3. So 7 pi over 3, I got to find that reference. Now, if I look at it here, so if I count it in terms of pi's over 3, I would go, this would be, sorry. It's not, oh, it won't go there. So anyway, let's go here. That'll be 3 pi over 3. That'll be 6 pi over 3. And then 7 pi over 3 is one more. So actually it's going to be pi about, let's go right about right there. It's not quite all the way through. Okay, so what it is the same as pi over 3. Okay, that's my coterminal spot there. So that's that. First of all, we recognize this quadrant 1, so it's all going to be positive. It doesn't matter. So with a tangent, so I'm going to evaluate the tangent, but the cotangent will also be positive. Okay, now to help with that, I need to find the cotangent of 7 pi over 3. For now, we haven't talked about using radians in the calculator yet. So instead, I'm going to do this with degrees. So I got to recognize what is pi over 3 equal to in terms of degrees. Well, that is equal to 60 degrees. Okay. So you can do this as, do your normal conversion where you multiply this by 180 over pi. So 180 divided by 3 is 60. So that's what this is here, is 60 degrees, which means this is a 1. I guess I drew that line a little too short. It's going to be more like this. Just try to make it a little bit accurate so it's not too confusing. So that's 60 degrees. We'll zoom in a little bit here. So that makes this 1, 2, and root 3 for my reference triangle. Okay. So what we're looking at there is, because it's cotangent of 60, then I am going to first figure out the tangent of 60. Okay. Well, the tangent of 60 is opposite over adjacent, so it's root 3 over 1. So that means that the cotangent of 60 is 1 over root 3, which is equal to root 3 over 3. All right. So that means the cotangent of 7 pi, this one right here, cotangent of 7 pi over 3 is the same as root 3 over 3. Okay. All right, next one. Exact value of cosine of 7 pi over 6. So I'm running out of space here a little bit, but if I, again, do my reference triangle, I got to find my reference triangle. So we're going to go 7 pi over 6. So this will be 6 pi over 6. So that means a little bit more past that to get to 7 pi over 6. Okay. So, and then if I use that as a reference idea, then I know that's going to be just pi over 6 is that one. Okay. So 7 pi over 6 is in this position here. Okay. We are in the third quadrant. So again, it's all students take calculus, only tangent is positive. So I know that in the end, this will be a negative sign. Okay, that my final answer should be a negative when I do this. So I got to recognize too that pi over 6. So that's how much this is right here, is pi over 6. That, if I convert it into degrees, is going to be 30 degrees. Okay, so my reference triangle I can use is going to be 30, 60, 90 again. Okay, so 30 degrees, 1, 2, and root 3. Okay, so I want, if I look at it as this one right here, I make the triangle here, it's 1, 2, and root 3. So what is adjacent over hypotenuse here? So the adjacent side is root 3, and the hypotenuse is 2. So in the end, and I can see it here too, it's technically a negative root 3, and it is positive 2. So the cosine of 7 pi over 6 is equal to a negative root 3 over 2. Okay, and that's it. So again, we did one more time on this one. We drew the diagram for the given angle, found our reference angle along with the sign that we need to use and the quadrant. We rewrote the expression using our information from there, so that the quadrant with the negative signs and all that. And then we evaluated it to get to our value of negative root 3 over 2. All right. So these are just going to be the challenge here is just making sure you understand, are they in the correct position on the circle? And then setting up your reference triangles every time. Okay. All right. The swing arms of the ride pictured below are 89 feet long, and the height of the axis from which the arms swing is 99 feet. What was the total height of the ride at the peak of the arc? All right. 1 second here. Yep. Sorry about that. I just had to double check the diagram, make sure I understood what we're trying to find here. So it's a little confusing because we got 2 swings in here, but if we just focus on this one, so this one is at its peak position here. It's as far as the swing will go. Okay. So because of that, we are trying to find this value of this height. We can make this right triangle off of this. Okay. So again, using this negative 200 idea, we're going to find out what is my reference angle right here. So if it's negative 200, you're going to go negative 180 to here. So this has to be another 20 degrees. So I'm going to redraw this reference triangle that looks a little bit more, hopefully a little more clear. So we got 20 degrees, we got Y, and we got 89. Okay. So the first goal is let's find the length of y. So we've got opposite and hypotenuse. So I'll set it up with sine. Sine of 20 is equal to y over 89 here. Go multiply both sides by 89. So 89 times the sine of 20 is equal to our y distance. So I'll plug that in my calculator real quick. Sine of 20. So that comes out to 30.4, let's just go 44 equals y. Okay, now the total height at the peak of the arc is going to be that plus the 99. Okay, so when I add those together, my total height is 129.44 feet above the ground. Okay, and that is actually going to be it for today. Okay, so again, what we're working with is doing our trigonometry with these general angles that are like this. So in this work problem, we have to first understand that it's going negative 200 degrees for its total swing, create that reference triangle. So that's what I rewrote over here. Use that to find the y value, and then I add that on to the 99 here. So that's how I get to my final answer. The other way we use our general angles is this way. Again, draw a diagram, figure out what quadrant you're in. You use that to figure out what sign you need to use. And that's that all students take calculus. So again, it starts in the upper right, quadrant 1, goes around in a circle like that, where all students take calculus. Okay. And that is it for today. All right. Take care, everyone.